over T. Now this is equal to 48.5 times 10 to the power minus 6 divided by twice 0.01. Okay, so 48.5 power minus 6 divided by 2 divided by 0.01 is equal to 2.425 times 10 to the power minus 3. Okay, I do it again, 48.5 power minus 6 divided by 2 divided by 0.01, 2.425. So you realize that alpha is higher. Okay? And I want you to focus on the first moment of area. If we look at the first moment of area, at point J, the first moment of area is smaller. At point alpha, it is what? It is bigger. Okay? The only thing common with point J and point alpha is what? The thickness are the what? Are the same. Okay, but you have a bigger what? First moment of area. You have to know the first moment of area and the thickness are always fighting against one another. Okay, and lastly, we want to find QZ at point beta. So this is where point beta is, right? So QZ at point beta will be equal to 48.5 times by 10 to the power 3 plus by the width is equal to 50. The depth is equal to 20 multiplied by 20 divided by 2. Okay, so this will be equal to 48.5 plus by 20 times 20 divided by 2 times by 50 is equal to 10 times 10 to the power 3. And this is equal to 58.5 times 10 to the power 3 millimeter cube, which is equal to 58.5 times by 10 to the power minus 6 meter cube. And we realize that over here, beta, we realize that beta over here is what? The QZ at point beta is at its maximum. Yes or no? The QZ at point beta is at its maximum. Okay. So from here on, I'm just going to do some work over here. So QZ at point beta over T, this will be equal to what? So it's 58.5 times 10 to the power minus 6 divided. Now the thickness changed to what? 0.05. So 58.5 power minus 5 is equal to 1.17 times 10 to the power 3 or minus 3. Okay. So from here, right, what do we realize? Okay, we realize that if we look at these values over here, okay, so over here, this is at beta, this is at alpha, and this is at J. Okay, we realize that the highest ratio is at where? Is at alpha. Can you see that? Okay, we realize that the highest ratio is at alpha. Okay. So when that's the case, we know that. So V over, or the QZ over T ratio is highest at point alpha. So therefore, tau max is equal to Vy over IZZ QZ at point alpha over T. Okay. So like what I told you all yesterday, tau max is at 130 times 10 to the power 6. This is Vy, and then your second moment of area is 4.86 times 10 to the power minus 6 multiplied by QZ over T, which is equal to 2.425 times 10 to the power of minus 3. From here, we can calculate the Vy is equal to 130 times 10 to the power 6 multiplied by 4.86 times 10 to the power minus 6 divided by 2.425 times 10 to the power minus 3. Okay, so 130, 4.86 divided by 2.425 is equal to 260.536 times 10 to the power 3 Newton. Okay. Now, that is not necessarily equal to our P. Okay. So yesterday, we drawn this. And we know that over here, we have a distance of 590 millimeters. And then from here to here, we have a distance of 550 millimeters. Okay. So over here, you will have a AY, and then you will have a BY. And the question asks us to determine what? Asks us to determine P. Okay, it asks us to find what is P. Okay, so we can determine the reaction forces. Okay, so I'm going to call this our X, our Y, rotation about Z. So we are going to do static analysis. So we're going to do summation about moment in the Z direction at point A is equal to 0. So you will have 0.59. So minus 0.59 P plus by 0.59 plus by 0.55, 1.14. And this is equal to your BY. The whole thing is equal to 0. So BY is equal to 0.59 divided by 1.14 E. Okay, so 0.59 divided by 1.14 is equal to 0.59 divided by 1.14 is equal to 0.518. Okay, then we do summation about forces. In the Y direction is equal to 0. You have AY minus P plus by 0.518 P. The whole thing is equal to 0. So therefore, AY is equal to 1 minus 0.518 is equal to 0.482. So now if we were to sketch our shear force diagram, it looks like this. This is our V, and this is our X. Okay, so we will have 0.482. Okay, we have 0.482. And then it comes down by 1 P. And then it goes horizontal. And it closes over here. So this is equal to 0.518 P. Okay. So we know that 0.518 P in terms of magnitude we know that 0.518 P will be equal to what? It will be equal to 260.536 times 10 to the power 3. Okay. So therefore, P will be equal to 260.536 power 3 divided by 0.518. So be equal to 502.965 times 10 to the power 3 Newton. That is your E base. Okay. Now, the next part of the question is more challenging. Okay, this part is straightforward. It's not difficult at all. You realize it's not just calculating numbers now. Yes or no? Right? It's not just you calculate numbers and you get your answer. No. Okay. You have to start making what? From those numbers, you have to start making decision. Okay. Now, the next part that we're going to do, same diagram. Okay. And I'm going to copy the questions for all of us. The wall thickness of the beam, okay, determine the wall thickness of the beam such that the maximum shear at the centroid and the region with the smallest wall thickness are equal. Okay, and it states, okay, it restricts that the outer perimeter of the cross section of the beam must remain what? Constant. So for this question, which is an optimization question, the external perimeter cannot change. Yeah, repeat again, the external perimeter cannot change. But what we want to do is we want to make, I'm going to call this alpha, and I'm going to call this beta. Okay, so what we want to do is we want to ensure that the shear XY at point alpha is equal to the shear XY at point where? At point beta. Yes or no? Okay. Now, question, what can we change? You can change the what? Thickness. So I have students telling me, Eugene, when you say thickness can be equal to this, or thickness can be equal to this. Yes or no? Wall thickness. So which one is correct? I have about this term test exam of question was maybe 2.5 years ago. A student thinking thickness is that way, and I marked them wrong initially, but later on I give them some marks because the mathematical expression is not so straightforward. So which one is correct? The vertical thickness or the horizontal thickness? Anyone? Oh, you know now with the horizontal thickness, right? Okay, but why? Why is it the horizontal thickness correct and the vertical thickness wrong? The thickness is dependent on what? What is the thickness dependent on? What did the rule say? The thickness is what? Perpendicular to the shear flow. So if we were to sketch the shear flow, this is our Q. Perpendicular means it has to be what? This thickness, yes or no? Right? And then it comes to your mind a lot. Okay, we have to write that expression. Then we have to know what is Vy over Izz, Qz alpha over T at alpha must be equal to Vy over Izz, Qz at point beta, and thickness at beta. So if it changes, what happens to your second moment of area? It will move, yes or no? It will vary, right? But for the fact, what did I say about one of the rules? B and I are what? Constant. You can drop this term. Yes or no? B and I are constant regardless of the point of influence. So for this case, you just need to find QZ alpha, right, over T at point alpha and QZ beta. T and beta we already know already. Pretty clear. Okay, that's how we solve it. Okay, I will solve it next week. Not next week, I'll solve it tomorrow. Okay, I'll see you guys tomorrow.